Welcome to Brain Vision.
In this problem, we have more capacitors, of course. We have two capacitors in parallel and a voltage, so we have the same voltage across them. We're told, let's see here, we're told that the first capacitor has a cross-sectional area of 1.5 centimeters squared. It has an electric field across this capacitor of 2,000 volts per meter. The second capacitor has a cross-sectional area of a capacitive area of 0.70 centimeters squared, and it has a electric field across it of 1,500 volts per meter. And obviously, we know the permittivity constant here. And so we know the electric field across in a capacitor is just the charge density, and this is the areal charge density divided by the permittivity. The areal charge density, assuming that we have a uniform charge distribution, is just the total charge divided by the area. And that is, then we can figure out the total charge on the capacitor is the electric field in the capacitor times the cross-sectional area times the permittivity of free space, since there's no, we're assuming that there's no dielectric material inside of there. So that we can then just simply calculate what is the total charge on the two capacitors. Well, we can figure out the charge on the first capacitor because we know A1, we know E1, we know epsilon naught, so we can figure out, and that winds up being about 2.66 picocoulombs. And then since we know A2 and we know E2, we can figure out what's the charge on this second capacitor, and that's 0.929 picocoulombs. And then the total charge is just the sum of those. So we just basically counting charges, and so the sum of those two is 3.6 picocoulombs. So that's the total amount of charge on these two capacitors.